Hi everybody, welcome back to my channel. So in this session, we are going to discuss very important protocol that is DHCP. So if you are working as a network security engineer, network engineer, cloud security engineer, cyber security engineer, it is very important to understand this protocol. Even in future, if you are planning to switch your job in security architect. So if you are designing any network, it is very important to understand about DNS, DHCP because uh, network will not possible without DHCP and DNS, right? So in this session, we'll cover about the DHCP protocols and how it works. This session will not long. I'm trying to just cover about DHCP, and I'm going to also show you like how we can see this in on the Wireshark capture packet. Okay, we can say like PCAP in PCAP file. So in DHCP, guys, there are four discrete steps are used between a DHCP client and DHCP server. Okay, client is consider your laptop. Server where we define our pool. Okay, and these steps can be remembered using the acronym. So basically, in network we use one acronym called DORA. Okay, so if you know DORA, means you are good in DHCP to understand. So DORA is a acronym we can say like of DHCP. Okay, so we understand DHCP with the help of DORA process. Okay, so consider this is your laptop and we have seated in your company, guys. Okay, and this is the DHCP server which is hosted somewhere on the DMZ. We can say like in your network in your company. So when any new laptop, or maybe you or me sitting in the office and connected through Wi-Fi. So and we are sitting first time in the office. So first DHCP discover message sent by client. Okay. And while sending this message, what will be the layer for information? So source port is usually 68, guys. So this is the source port for the client. And sometimes this question generally asked in the interview also. So source port will be 68 and destination port will be 67. And these are the UDP port. Okay. And what is the L3 information? Because this is the first discover message. So it will contain like 00. And destination is broadcast 255, 255, 255.255. And it is going to tell to the DHCP, may I have information, may I have IP information, please. So DHCP client is sending this message to the, we can say like DHCP server. So this is called discover message. Okay. Then DHCP server is going to send DHCP offer message. And it is telling like I can give you IP 77751. It is in our list. We can say like it is in our pool and it is available. So it is going to mention source it's we can consider this DHCP server IP, and the IP which is free and which is assigned to the client is 7.7.7.51. And what is the source port here? 67, because server is sending giving IP, we can say like offer. And what is the destination port? 68, because this offer is given by DHCP server to the DHCP client. So this is called DHCP offer message. Okay. Then third message is guide DHCP request. Okay, DHCP request. So someone may be confused like why DHCP request? If you know client is requested like DHCP discover and DHCP offer the IP, then why request and acknowledgement required? Okay. See, server has given the IP detail, but how server you know like client has acknowledged it, right? Whatever IP I offered, client is accepted and acknowledged it. How we can know that? So for that DHCP client, we can say like our laptop is sending DHCP request to DHCP server. May I reserve the IP info you gave me? And it is very interesting, guys. Again, it is using source port 68, destination port 67, and source is source IP 00. And again, it is using broadcast, destination as broadcast IP. Okay. Region is, guys, in company, we use multiple DHCP server. We can't keep one DHCP server, right? So this message indicate that, for example, if earlier DHCP server is down, which offer the IP like 7.7.51. So in this scenario, maybe other DHCP will take as a role. Okay. So for that purpose, this message basically indicate also it is telling to please reserve my IP, whatever you gave me earlier. Okay. Then DHCP server is going to send ACK. Okay, that IP is now reserved for you, and this IP is reserved for you. It is not going to be assigned to anyone until it is free. Okay, until it is unused. So it is using destination as a 77751 means this IP is going to assign to this client, and source is DHCP server IP, and destination port is 68 because DHCP server is sending request to the DHCP client, and source port is it 67. So this is how DORA process work in DHCP, guys. Okay, please comments if you have any doubts and are still in the process, guys. Okay, so this is about DHCP in IP version 4. Okay, that's called DORA process. In IP version 6, guys, I'm not going to explain in depth IP version 6, but I'm going to tell the acronym so that we may be aware. The process is exactly same, but for understanding this thing, we should be familiar with IP version 6 IP. Okay. So in IP version 6, these steps can be remembered using the acronym SARR. In IP version 4, it is DORA, but in IP version 6, it is SARR. Solicit, advertise, request, and reply. The process is same. It's kind of discover, then it is for we can offer, and this is request message, and this is acknowledge. So you don't need to confuse, guys. Just remember the acronym SARR, solicit, advertise, request, and reply. Okay. Second thing, guys, is it very important to understand some other DHCP message type, because if you know DORA process, that is fine, but you should also know about some other DHCP message. For example, DHCP release. So DHCP release message basically used by client means our laptop to inform server that IP address is no longer needed any and may be placed back into the DHCP pool. So DHCP release means client is sending that message to the DHCP server. So like whatever IP assigned to me, this IP not in use at the moment, so you can keep that IP in your pool, DHCP pool. So that is called DHCP release message, and it is sent by DHCP client. Okay. So it is very important to understand these messages also. So basically, these are the other types of messages. Okay. Then DHCP negative acknowledgement. Okay. And it is sent by DHCP client may request an address that was previously used by the same client. Okay. For example, guys, this is our laptop or our desktop in the company, right? Maybe we have get the IP like 10.10.10.10 from DCP server. Maybe someone has removed the NIC card of the maybe local IT team removed the NIC card because of some issue, and after 1 hour they put new NIC card, but the operating system generally run in the backend, guys. Okay, operating system generally run in the backend. Okay, so they have the details about the IP. Okay, so once NIC is connected, it is going to send one DHCP negative acknowledgement. Okay, please, it is possible to assign the IP which was using earlier to the DHCP server. That is called DHCP negative acknowledgement. I don't know, like many people not aware about, I'm pretty much sure like many people is not aware about this concept, these messages, and it is very understand, important to understand from, if you want to be good in this technology. Okay, so if the address has subsequently been allocated to a different client, DHCP server send DHCP negative acknowledgement. Okay, so for example, you are requesting your previous IP, but that IP is already assigned to some other PC, some other laptop. Then DHCP server is going to send, okay, sorry, it is not possible to assign the IP which was used earlier. That IP is reserved or assigned to someone else. Someone, we can select other laptop or desktop. So that is called DHCP negative acknowledgement, guys. Okay. So it is very important to understand. Okay. Other message like DHCP info. So basically DHCP inform used by the client means your laptop, our laptop, who already has an IP address but requests additional parameter from DHCP server. So for example, this is our laptop and we have already get IP from DHCP server like 10.10.10.10. But some information is missing like DNS server IP, default gateway IP. So that message basically can be we can say like sent by client in DHCP inform message. Okay. And then last one is DHCP decline messages. So basically used by client to inform server that parameters contained in the DHCP offer were unacceptable to the client. Okay. So for example, whatever details is getted by DHCP server and that is not correct, we can say. So at that times DHCP decline messages can be sent by client like your laptop, our laptop, or maybe desktop. Then at that time, DHCP process must be a start over. So in this situation, DHCP is going to a start. We can select DHCP process is going to a start from beginning. Like DORA, we can select discover, offer, request, acknowledgement. So this is about DHCP, guys, how it works and it messages. Before closing, let me show little bit about the some Wireshark capture like PK file. So we don't if you have a capture packer already in your system, that is fine. Otherwise, just search like DHCP um, packet capture CloudShark. So it is, we don't need to download any Wireshark and all, it will be open, okay? Directly in Wireshark, we can say. So this is, we can download from the, and we can open from the CloudShark website, okay? So this is guys DHCP discover message, offer, request, and acknowledgement. So you can open all message one by one. So see, what is the source port here? Let's understand from the layer 4 perspective. Source port 68, destination port 67. Whatever I have shown. Okay. What is the IP? Source IP 00, source IP 00, and destination IP broadcast 255.255.255. Because client is not know who is the server, where is the DHCP server. So it is going to broadcast to all the we can say all the network, and the DHCP generally sit on our network, right? So it is identify and get IP from DHCP. Okay. So you can also see these things in Wireshark also. And yes, one more thing I want to tell guys, if you want to become good in any protocols, try to read the capture. Try to read the PK file guys, like DHCP, DNS, or NTP or other protocols. So this is about the DHCP and how it works and its messages. I hope this video is useful for you guys from knowledge perspective. If you really like my efforts, please share, like, subscribe as much as possible. Let's meet on the next session. Thank you very much, everybody.